So good afternoon, everybody. My name is Zaki, and I'm presenting mixed reality and BIM applied for construction health and safety. Under the supervision of Professor Sousa and Mr. Ricardo and Mr. Manuel from the company. First, the overall goal of this research is to reduce the high accident rate on the construction site. I will talk about the health and safety and BIM implementation in health and safety construction management. And then I will propose a framework for managing health and safety in construction using BIM and digital twin. First, we can see in this statistics in 2021, it's the highest accidents rates among all industry sectors are recorded in construction industry compared to manufacturing, agriculture, transportation. That's because construction sites are dynamic and there is always lack of integration between the digital and physical world. In the next statistics, we can see the most main causes of fatal injuries are fall from height, struck by moving vehicles, and struck by falling objects. BIM has been implemented to manage all the risk information in different ways. For example, BIM Level 3 suggests to use a fully integrated process with a single online shared model in a common data environment, which offers a reliable system that record and register health and safety information. Another example is virtual walkthrough. Virtual walkthrough, which simulate the view of a person walking through the building, can rapidly improve stakeholders' understanding of the project, which help to identify construction site risk information at early stages. Training workers. The use of virtual reality to provide 3D environment for training site workers can help the workers to train and simulate their operation methods. Another example is using construction site optimization using computational design. For example, we can assign some rules using machine learning to identify safety zones around the equipment, can optimize the crane position, find the best way of routes for vehicles. However, because of construction projects are always changing, BIM itself cannot manage these unplanned changes. So to manage those unplanned changes, it is important to track hazards in real time. And BIM, with the use of BIM and different information technologies like digital twin, where a virtual environment can accurately position both static and moving objects. The corresponding data from the real world can then be collected in real time, and mostly importantly, information of hazard could be delivered in real time, and then mitigation can be done. So my framework proposal is to develop a cloud-based digital twin that integrate data collected from multiple sensors with a BIM-based model. The framework aims to monitor heat stress in the workplace and near-miss accidents. Then automatically send warnings alerts on the runtime to the health and safety managers and workers to prevent any accidents from happening. So first, we should have a construction site model, which is the departure model that developed during the design phase. I propose to use a 4D BIM construction site model as a visual and a digital input sources, linking project activities to timescales and duration, which provide an advanced visual construction sequence models. So precise monitor of the progress of the construction site and health and safety information. The design model should be detailed, should be completed. It should be include all the construction site components and their elements. To facilitate the development of the construction site model, it is recommended to use a 3D parametric library like BIM object library that containing BIM objects as a basic component of the BIM model. However, Because of insufficient number of BIM resources for site elements, the designer may have to develop his own BIM objects. People, which includes workers, operators, pedestrian, equipment, such as mobile large-scale equipments, site works, building site works, structural materials, decorative materials, safety objects, etc. I defined the level of geometry detail, which is in general 200. It should be a generic shape with a simple model. The selected level of geometry detail is 200 because to simplify the process time for the object when construction site is big and contains hundreds of workers. Moreover, there is no benefit in having detailed 3D objects, since the goal is to identify the risk information related to it, which will be recognized from non-graphical information. So after having the departure model, we have a problem that there is a gap between the construction site model that has been developed during the early stages and the reality, which is the construction site exists or it has evolved. That's because maybe sometimes there is a defect or deviation between the designed model and the actual progress of the construction site. So to close this gap between the reality and the digital model, it is recommended to use reality capture devices that capture the progress of the construction site. The selection of reality capture devices, it has some criteria. It depends on the construction site. For example, outdoor environment. Drones that have high quality RGB sensors or have LiDAR devices is good for outside. That's because it provides safer, more efficient option than other reality capture devices. Drones can capture aerial data faster than other reality capture devices. For indoor devices, for indoor environment, I suggest to use mobile mapper devices because it's faster to capture a building compared to traditional methods. Mobile mapper device enable the use to scan a walking speed, can reduce the number of scans. It can help limit the time spent on the setting up and lining up the scans compared to traditional scanning. For narrow spaces, there are now new iPhones, new iPads that occupied with LiDAR devices. It can give you within a few minutes point cloud of rooms or narrow spaces like mechanical, electrical, plumbing rooms, etc. So selection of reality capture devices depends on the construction site and its element. After having this cloud, we have to update it fast. Usually it is a manual process to update point clouds and convert it to a digital model. However, it is important to use a semi-automated or automated methods that involve machine learning to convert this point cloud into 3D. The first step is classify entire point clouds into predefined groups, such as terrain, roads, surface, trees, building, roof, vehicles, etc. This process will separate the point clouds into groups based on the predefined category labels. Second step is to separate and isolate the class object that we need to process or to develop. We have to clean them first from unnecessary data, and then the idea is to improve the accuracy of the process and accomplish an accurate digital model. The third step is to generate the digital model after classifying and isolating the object that we need to develop. We convert it to a 3D model through algorithms and machine learning. The last step is to integrate this developed BIM object into the BIM authoring tool model. After we have this model that is updated, it depends on the construction site. We have sensors that collect live data from that is deployed in the physical assets, which is the construction site. So the sensors are deployed in the construction site, collecting data on a predefined intervals, and then send it to the cloud through gateways. So the selection of sensors where for the temperature sensors is with the wet bulb gulp temperature sensors which can measure workplace environment heat. For tracking resources, I'm using a proximity warning system, which is based on radio frequency identification. It's based on you have a tags that were attached to the equipment or attached to the worker through hat or attached to the workplace. So integration IoT data with BIM building information modeling. It is a big issue usually. That's why I suggest to use a digital twin platform. The digital twin platforms usually would host SaaS products, including application, authoring tools, data management, and can help retrieve IoT data from a database and map them into the BIM object. BIM, yeah. Two examples we can see: Ecodomus, Autodesk Forge. They are PaaS, which is a cloud-based development, and it is a set of APIs that help integrate different solutions together. However, to map the sensors data into BIM model, it is important to create a family that hosts the information from IoT data. For example, we have a worker. We should have non-graphical information as personal tag ID, age, gender, work type, etc. And equipment, sensors data, for example, temperature, humidity, data, date, time, sensor ID. This information will help analyze the risk for later and help analyze the risk later. Visualization of risk information. I suggest to use heat map analysis that allow the user to quickly and clearly identify data when exceeded a predefined acceptable range. In addition to the heat map analysis, a decision-making dashboard may be added to the view. The same thing is for near-miss accidents. I suggest to use heat map analysis to understand the level of risk. Decision-making dashboard can be added to the viewer also to visualize the risk information together with the heat map. In addition to graphical information, non-graphical information should be visualized. The code of practice pass 1192 set mandatory, recommended, and optional risk information to be shared. So for example, risk name, risk category, risk description, these are all mandatory to share with all the participants. And here we can see an example of risk information for graphical and non-graphical information. And in addition also to visualization of risk information at the runtime, it is important to save historical data, to do the long-term analysis. It should be stored in a database, and it should be, this will help for future investigation, pattern analysis, and optimizing the work condition. Feedback to the physical environment. So when the sensors collect the data from the physical asset, it's sent it to the cloud. And when the alarm will trigger when this data exceed a predefined accepted range. The clouds will send alarm or warning to the worker, to operator, and safety manager. To the safety managers, such as it will be through wireless connecting devices such as smartphones, it is necessary for him to take measurements to mitigate this risk information. So, conclusion, BIM integration with IoT data to create a digital twin in construction industry provide useful information to monitor health and safety. The framework addressed two issues of many issues in the construction site. It could be a step towards improving construction health and safety, connecting the physical and digital world. Thank you.